I'm Al Winchick. I'm the NRESi Research Manager, and welcome to the first Friday colloquium of the winter session. I introduce Stefanie here shortly, but before I do that, I got to have a couple of announcements. One is about, I sent out an email to the grad students and the faculty about the Canadian Institute of Forestry is having a Masters Night on Thursday, February 18th, 2016 from 7 to 9 p.m. And it's an add-on to the UNBC grad conference. So we are currently soliciting presentation abstracts from NRESi grad students who want to talk about their planned, their ongoing, or their completed research projects, and we'd kind of like to get 4 to 5 presentations to fill the evening. So if there are any grad students in the attendance that are interested in presenting to the CIF, please come up and see me after the presentation, or if there's any faculty here that think they have grad students that, yes, they should be presenting at that, come talk to me too. And we are offering a small honorarium to the presenters. Next week's colloquium will be Dr. David Connell from UNBC, and he's going to be talking about protecting farmland in northern BC through land use planning, critical assessment. So now I would like to introduce our today's speaker. So Steffie is recently she completed her bachelor's at the University of Toronto with a specialization in animal behavior, and finished her master's at McGill University in Montreal on chipmunk behavior. She recently completed her PhD here at UNBC looking at the effects of noise on Chickadee communication. She's currently working on a postdoc with Dr. Ken Otter, and her interests are animal behavior, how humans influence animal behavior, science outreach, and in particular citizen science. And she's originally from my home province, Ontario, from Muskoka, and she's going to talk today about her PhD on chickadees.
Hello? Oh, there we go. All right. Well, hello, everyone. Thank you for coming today to hear about singing through the noise and how birds compensate, and in particular, how chickadees compensate for the effects of noise on communication. So first, I'm going to talk a little bit about me, because some of you may not know enough about me. We're also going to talk about what the problem with noise is. What are we talking about here with respect to birds? Then we're going to go into the work I've done through my PhD and a little bit through my postdoc, looking at chickadees and noise. And when you want to see how do birds deal with noise, we need to ask 3 questions. Is there a problem? Should they actually be responding to noise? Does it actually interfere with their communication? If they should be responding to noise, how do they respond to noise? And if they do respond to noise, how is this response actually helpful? Because it may not be. So we're going to go through those 3 questions with chickadees later on. So first, about me. As Al mentioned, I'm from Muskoka, Ontario. I grew up in cottage country. The question I get from people who actually know Muskoka are like, you actually lived there? You didn't just go there? No, I grew up. This was not my backyard, but pretty close to it. I spent a lot of time outside watching animals, just enjoying the world around me. My parents were really big on getting out of their hair and being outside and not being in the way. Through this, I sort of developed a real big interest in animal behavior, and through my undergrad in communication and in birds, I was just really fascinated by how animals communicate, because a lot of the things when we see animals doing really weird things, the weirdest or the most sort of big ones we see tend to be communication. So that's where I got that interest in communication. So as Al mentioned, I did my bachelor's at the University of Toronto with a specialization in animal behavior. So you're seeing a theme here. At McGill, I worked with chipmunks. Sorry, not poo monks, but chipmunks. And that was away from birds, but it was still animal behavior. And I was looking at how they, initially the idea was to look at how did they deal with humans' handouts, so human feeding, and how did that change their behavior. And then eventually it didn't work. So we turned it into what kind of activity patterns do chipmunks have? And as many of you are probably aware, I did a PhD here with Ken Otter looking at chickadees and how do they deal with the effects of urbanization and noise. And currently I'm doing a postdoc here. So what is the problem with noise? So we often think about the problems with urbanization. We've got a rural habitat and we have an urban habitat, and they're very clearly different. Our rural habitat's got a lot of vegetation. It's kind of messy. Our urban habitat's very organized. It's got pavement, it's got houses. Things that you don't see here are the train tracks and the two bridges that are going sort of right beside you if you're in that park. This is Eliza Lake, sort of our forest here, sort of one of our research forests. And this is Kamloops down by the river. Something that's not immediately apparent is that they also differ very much in what they sound like. So I actually had to work hard to find a recording in which you could actually hear something in it, because these areas are really quiet. Now, if you catch it right at the dawn chorus, it's actually quite loud because there's lots of birds singing. But in general, it's really quiet. Now, this might be a little bit louder. So this is Kamloops. And so it's fairly different. There's a lot of traffic noise. It's pretty steady, even though you can hear the rise and the fall, the general background noise persists. And so as you can see, there's a pretty obvious difference between these two places. And the one thing about noise is that it's not only associated with urbanization. This area, if it was on the Highway 97, you may not have as consistent noise traffic, but you definitely have a lot of noise, even though it's a very natural area. So there are lots of problems with noise. We know that studies have shown that noise actually increases the stress in birds. It increases the stress in humans too, incidentally, but birds feel a lot of stress. And we think a lot of the reason for that is because it increases predation. So it increases your stress of being predated because you can't hear the predators around you. This also contributes, another problem with noise is that it interferes with the way that you can the communication between species. Not so much with visual communication, but with auditory communication. As many of you are probably aware, a lot of birds, particularly songbirds, the majority of their communication is vocal. So if you can't hear each other, you can't do most of what you're supposed to do. Altogether, these combine to have problems with breeding. So if you're stressed out, and you're spending a lot of your time looking out for predators, if you're being eaten more, if you are having a hard time communicating, and when we talk about communication, that's communication between males and females in terms of finding mates and retaining mates, but also between adults and their offspring. So all these things together can combine to reduce breeding success, and this is a problem for birds, particularly if we want to keep them in urban areas. So birds can adjust their communication to noise. So they're not just subjected to noise and are having to deal with it or sort of put up with it, but they can actually change the way that they sing or to mitigate these effects of noise. So for one thing, they can avoid noise. So they can change where they sing. So this means that we've seen that distributions of birds have changed depending on noise. A really interesting study was actually where they created phantom roads. So they went into a forest and they actually put up speakers and they broadcast either road noise or no noise or sort of background noise from these speakers. And they found that when they broadcast road noise, birds left the area. They can also change when they sing. And so this is more of a temporal rather than a spatial change. And so studies have shown that, say, for example, European robins will switch in noisy areas. European robins will actually spend more time singing at night. And the idea is that night is much quieter. And they can sing through the noise. And as you can tell from the topic of this presentation, that's what I'm mostly concerned about. And they can change how they sing. They can change the songs that they sing or the vocalizations they use. And they can change the structure of those vocalizations as well as how they use them. So when I say singing through the noise, there's actually several different ways that birds can do this. So they can sing more. So they can sing longer songs or greater output. In this particular case, we're talking about the chaffinch. These guys have been shown that at waterfalls, they actually sing more repeats on their songs. So they sing longer songs when they're being masked or overlapped by background noise. And that is a redundancy. It means the more you sing, the more vocal you are, the better the odds that someone will hear you. They can also sing louder. So the nightingale in Europe, they've done studies showing that nightingales will actually sing louder notes and louder songs when they're being overlapped with background noise. Now this seems really obvious because it's kind of like what most of us would do if it gets really noisy And we're fairly certain that many birds do this, but this is actually one of the only studies I know that's actually tested it, because it's really hard to test how loud a bird is singing in the wild, because the moment they move their head, you have a different measurement of how loud they're singing. So this is actually pretty impressive that anyone was actually able to establish this at all. They can also sing sort of the structure, change the structure of their song, so they can sing more clearly. And the example here is with the red-winged blackbirds, in which they've changed their songs in noisy areas to being less buzzy and a little bit more tonal, so less complex. And finally, the part that I'm really interested in is that they can sing higher. So when there's a lot of background noise and it overlaps a signal in the same frequency, it's perceptively very hard to hear. It's called masking. But if you shift whatever you're saying to a higher frequency, you're being released from masking, and the perception of that signal is much easier. In urban areas, most of our noise, or any noise created by humans, so anthropogenic noise, is usually low frequencies caused by traffic, it's caused by cars, or machinery, or trains, things like that, and it's generally low frequency. So if you can shift your songs to a higher frequency, you can experience masking release. And so this is a great tip. In in Britain, they did a really big study. It was one of the fundamental studies, the studies that started off this whole idea that noise affects the way birds sing. And they looked at a bunch of different city-rural pairs, and they found that in every paired situation, the birds inside the city sang higher frequency songs than the birds outside the city. So today, I'm going to be talking about singing clearly and singing higher, because I'm looking at two different species of chickadees. So black-capped chickadees and mountain chickadees are two of the species of chickadee we have here in British Columbia. There are a couple other species, but these are the ones that we actually find in Prince George regularly. Blackcaps are really common, and mountain chickadees are less common, but still there. You find them more often in the drier areas down south, like Kamloops and Kelowna. But what's really interesting about these guys is that they're closely related. They're actually so closely related they can hybridize in some places. But despite that, they have I shouldn't say very different, but they do have different singing behavior. So they sound similar, and they sing similar types of songs, and they call similar types of calls, and they're closely related, but they still use different behavior. So the black-capped chickadees individuals pitch shift, which means that they sing some of their songs at a higher frequency than others. And an individual will actively adjust the frequency at which he sings. And I'll have an example of this for you in just a moment. Black-capped chickadees also sing the same song pretty much no matter where you go. In Vancouver, I found that they actually inserted a little click in the middle of their song, so it was actually kind of interesting, but that is one of the biggest changes I've ever seen in black-capped chickadee songs. So they have a very similar song across their population range. And blackcaps in the dawn chorus, which is about 45 minutes, first thing in the morning when the males get out there and they strut their stuff and they sing and they sing and they sing and they sing. These guys pretty much only use songs. You'll hear the occasional call, so the chickadee-dee-dee, but it's not very common. Mountain chickadees, on the other hand, the individuals don't vary their song. If they have a song, when they sing their song, they pretty much sing the same thing over and over and over. Occasionally they'll drop a note or add a note, but they don't shift the song up and down. However, if you look at a song from a mountain chickadee in Kamloops versus a mountain chickadee in Williams Lake, they sound entirely different. There's a huge amount of regional variation, so variation between the populations. And what's also interesting is that we're not even sure why, but these guys use both songs and calls in the dawn chorus. And so some individuals will use only songs, and some will use only calls, and some will switch back and forth between the two. And they'll often sing in bouts. So as I mentioned, they have very similar vocalizations. So this up here is a black-capped chickadee call. I think many of you are probably familiar with this guy. So this one is a little bit different, but you can hear the similarities in the structure. Their songs, both species, are very whistled and very tonal, as opposed to the calls here, which were very broadband and buzzy. So they are much fuzzier signals. These guys, so this is going to be an example of the black-capped chickadee song, and you're going to listen, and you're going to listen, just make sure. Sorry, but you're also going to hear a pitch shift in the middle. Sorry, we're going to listen to that whole thing over. There we go. And so this hasn't been edited. This is exactly how it sounds like in the field. So in the field, you're listening, you pitch shifted. And sometimes when I'm really tired in the morning and I'm recording my mountain chickadees, I'll have a little bit of overlap in where the two birds are. And I'll be like, okay, I got a mountain chickadee, I'm recording him. Oh crap, he just pitch shifted. He's totally not a mountain chickadee. Because they're so similar, if I'm not really paying attention, I will sometimes make that mistake. And it's not until I hear the pitch shift that it kind of kickstarts my brain into high gear and being like, nah, wrong bird. So this is an example of a mountain chickadee. And having said that story, you're going to listen to this and be like, yeah, they don't sound anything alike, but. You can hear how the tone, the sound is very similar. And so this kind of song will be interspaced with, there'll be sing, 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 and then there'll be a couple calls. And they might go through longer bouts or shorter bouts. But in general, as you hear, there's pitch shifting in the blackcaps, and there's really a consistent song in the mountain chickadees. So this set me up to really nicely explore how their different natural behaviors might influence how they deal with noise. Because we know that phylogenetically, they're very similar. So now we can start to use these different starting points as ways to explore how different types of birds are affected by noise. Because if we can predict what a bird will experience, what a bird's response to noise will be, it'll give us a better idea of which birds are going to be susceptible or to noise and to urbanization, and which birds are going to be better off. So, getting on into the meat of the presentation. First, I'm going to look at this idea of signal propagation, because we suspect that chickadee songs and calls are going to be affected by noise, but we should really look at that first, because if they're not affected by noise, then the whole rest of my study is kind of a moot point. So first what I did is I went out and looked at the relative effects of habitat, so urbanization and noise, on the propagation and transfer of chickadee signals. This one was just through recordings. Next, I looked at signaling patterns. So I wanted to see how did noise affect the normal signaling patterns in these two chickadee species. So how did they change the way they sang? And finally, because I did find differences in how they changed the way they sang, I wanted to know, were these actually helpful? Were these differences actually improving communication? Could they actually hear each other better? So obviously you can't do this without any help, so I had a lot of technicians to help me. I have Laura Kennedy, James Bradley, Samantha Krause, and Kristen Marini, and Alex Coiter, who all came out very early mornings, a lot of work. So I really need to make sure that everyone gets thanked appropriately. But having said that, let's go right along. So looking at signal propagation. So in this study, I looked at both species, mountains and black-capped chickadees, and I looked at calls and songs. And I looked at how these calls and songs changed when they were transmitted, sort of broadcast by a speaker, through the environment to a microphone over here. So this was 75 meters, and I did it over 37 sites. And these sites varied over different types of habitats, so open through closed, as well as different noise levels, so noisy through quiet. And this way, I could tease apart the relative effect of habitat and noise. So what I found, sort of briefly summarized, was that for both songs and calls, they were masked by noise. If you look up here, this is looking at songs and calls, songs up here and calls down here, for the signal to noise ratio. And that is the ratio of how much signal there is to background noise. So a higher signal to noise ratio means that calls are more audible, or songs or calls are more audible. A lower signal to noise ratio means that you're starting to have a hard time picking out that signal from background noise. So as you can see, if we look at with increasing ambient noise down here, that the signal to noise ratio of both songs and calls decreased. So noise was definitely masking our songs. We also found that noise degraded our songs and calls. So degradation really just means that we're changing the structure of the song. So the song, it does not sound like it's supposed to. And I measured this, among other ways, by looking at the loss of minimum frequencies. So I looked at the calls and the songs, and I looked at how many frequencies at the bottom of their call or their song that they lost, that I couldn't detect because they were just buried in noise. And what we can see that in both songs and calls, once again, as ambient noise increases, we increase the amount of frequencies we lose. So we lose more and more frequencies up the bottom of the song. But I found no effective habitat openness. So habitat openness really didn't have any effect on the degradation or masking of calls. And one thing else I want to point out is this comparison of songs to calls. Is that if you look here at the units, these units here are both in kilohertz, but the range for songs was up to about 0.1 kilohertz. So that's about 100 hertz. So songs lost about 100 hertz on the bottom of their vocalization. Calls, on the other hand, lost up to 1.5 kilohertz. So that's 1,500 hertz. So the effect on calls was way greater, way higher than the effect on songs. So this gives us something to look at with respect to mountain chickadees. Because we know that mountain chickadees use songs and calls during the dawn chorus, we can start to look at it from the perspective of saying that, well, perhaps they should use songs when it's noisy, because songs are less affected by masking and signal degradation. So for this part of the study, very quickly, we found that noise generally affects signals more than habitat urbanization. And noise definitely has the potential to interfere with chickadee communication. That's good, check. Now we can do the rest of our study. We also found something interesting that will affect our hypotheses for the rest of the studies, is that songs are better signals to use in noisy conditions. So you notice that here I also looked at habitat urbanization, but for the rest, because we found no effective habitat urbanization here, and in general in my PhD that was a theme that continued on, that there was very little effective habitat, most of the effects I found were of noise. So I'm not really going to discuss it further. So the next study I did was that, okay, we know that noise affects how how well chickadees vocalizations travel. Can chickadees do anything about this? And then next, will it work? So we looked at this in two different timescales. So we looked at the effects of local ambient noise. So how much did the ambient noise around a chickadee's environment affect the way that they sang? And that's a long-term, that's looking at the long-term effects of noise. And then I also looked at the effects of experimental noise. And so this was a short-term blast. So I got my speaker out, I found my bird, I recorded my bird for 5 minutes without doing anything. I set up my speaker and I blasted that poor bird for 5 minutes of traffic noise. And then I recorded it while I was blasting it with traffic noise and then afterwards. And so this gives me an idea of within 5 minutes, can those birds change the way they sing? Can they really switch on the fly? Because populations that adjust only in the long term, but not in the short term, are probably not going to be as, well, by definition, they're not as flexible as a population that can adjust in the short term as well as in the long term. So with black-capped chickadees, if I looked at long-term effects of ambient noise, so what I did is I correlated the local ambient noise with the frequency that the birds were singing. We found a really clear positive trend that birds in noisier areas sang higher frequency songs on average. They are pitch shifting still up and down, but the average song that they're singing, or in this case, the average frequency of their lower songs were all higher. When we looked at experimental noise, what we expected to see was that during noise exposure, they would be singing higher frequency songs than before noise exposure, because that seemed like a really good adaptive response. What we actually found was something, well, we did find that, but it was complicated. So what we found was that background noise, so the ambient noise, also had an effect. So when I put out my speaker and I played back experimental noise to these birds, birds in quiet areas actually shifted down. So this is a comparison. So this means 0 means they didn't shift, below 0 means they actually shifted down, and above 0 means they shifted up. So birds in noisier areas shifted up, and birds in quieter areas shifted down. So this made us think that there was something to do with the background noise that affected their behavior. With mountain chickadees, when I looked at the long-term effects of noise, I found a regional difference. So remember, the mountain chickadees are the birds that show a lot of regional variation. So we found that Williams Lake and Kelowna both showed positive trends. Their songs were higher in frequency in noisier areas, but not in Kamloops. In the short term, we found that they actually changed the frequency of their calls. We didn't test this in black-capped chickadees because they don't really use it during the dawn chorus. But because mountain chickadees do, we had to look at it. But it's a very short-term change. It's only really during a noise exposure, and within 5 minutes after noise exposure, they've switched back down to their normal frequency. We also found that they changed their song-to-call ratio. But just as with the black-capped chickadees, it really depended on the levels of background noise. So in quiet areas, they actually did what we didn't expect them to do. They actually started calling more. And because we know that songs transmit better than calls, we thought this was a kind of weird response. In noisy areas, they did what we thought they ought to do. They actually started singing more than calling. So to conclude for this section, we found that black-capped chickadees do use their pitch shifting, and they shift the frequencies on the fly. So they had this ability to quickly adjust to noise, both in the long term and the short term. So when we played back experimental noise, they changed, and we played back, when we looked at the correlation with long-term noise exposure, they also changed. With mountain chickadees, they seem to have two different strategies. So black-caps, we were only looking at frequency, but with mountain chickadees, they had more strategies open to them. And they changed the song frequency in the long term, but not in they weren't able to do so in the short term. But they were able to change their song-to-call ratio in the short term. And so that gives us the idea that given time, they can adapt to noise. I don't personally really consider this one to be a great strategy for dealing with noise, because we do know that songs are still masked by noise. They're better than calls, but they're not great. However, in both species, we still found that these quick reactions still depended on background noise. And so there seems to be something about experience or familiarity with noise. And another thing that we haven't really explained is why the reverse pattern in quiet areas. So why did birds in quiet areas sort of act counterintuitively? We think it might have something to do with different types of noise. So possibly in quiet areas, the natural noise is usually short duration, so there might be a different strategy with how you deal with it. Or in quiet areas, noise is usually high frequency because it's from other birds. So perhaps because of these reasons, the birds have different strategies for dealing with noise, and through experience with urban noise, they develop a new strategy when it's when they're in a noisy urban area. So here we found that birds, mountain chickadees and black-capped chickadees, both have strategies for dealing with noise, but we don't actually know if it's helpful. So we decided to look at their perception and response to these two different signals. So we use playback experiments. These are experiments that you can use to assess how well birds respond to the recordings of different songs. So essentially, we take out our speaker again, and we play back one song to a bird, and we record its response. And then we play back another song, and we record its response. We compare the differences in those two responses. So you can use this to figure out differences in attractiveness between your two signals, aggression, or in our case, we were interested in audibility. So with black-capped chickadees, it was pretty straightforward. We know that they shift their songs up in noise, so we really wanted to see, are high songs more audible than low songs? We also knew that in black-capped chickadees, they don't really pay attention to the absolute frequency. So absolute frequency isn't a signal. It's the shifting between frequencies that is important to them. So we had no reason to expect that they would respond more to high or low in the absence of noise. So when we did this experiment, we just compared high frequency songs. So these are little spectrograms here. By the way, this is time. The color is amplitude, and we've got frequency going up here. So we have high frequency songs compared to low frequency songs. And this fuzz in the background is background noise. So you can see that these guys are just above the background noise, and these guys are embedded in it just a little bit here. So if we compare how birds react to these two different songs, we should be able to figure out whether or not they can hear high songs better. With mountain chickadees, it was a little bit more complicated. We know that they respond to noise and that they shift their songs to higher frequencies, but we also had some evidence that I didn't present here that they repeat some of their high frequency notes. We also knew from a playback study I did during my PhD that the high notes might actually signal aggression, so it might not just be audibility. So we needed to design an experiment that would take that into account. So what we did was 2 experiments. We did one with the noisy background and one with a quiet background. And that's what this looks like. So here, our high notes are just repeated, 4 notes all repeated very high. And our low was a song with 2 notes high and 2 notes low. And what we did was we did one experiment with noise in the background and one experiment with just a quiet background. Because if the signal is aggressive, if high frequency notes are aggressive, what you should see is that in this experiment, birds react more strongly to these songs than to these songs. And then there should be either the same, if they can hear no problem up here, or there should be no difference. But if it's audibility, what we would expect is they would react more to these songs than to these songs, and there will be no difference between low and high in the quiet. So when we looked at the black-capped chickadee experiment, we found that males were reacting more quickly to high than to low frequency signals. But this was complicated because this only happened if high frequency stimuli were presented first. So what this means is we had an effect of playback order. So here we've got latency to the first reaction. So quicker reactions are lower down and slower reactions are higher up. We considered a quick reaction to be more aggressive and also to show that they could hear the song better. So when we played the high frequency songs first, they reacted very quickly to those songs, and they reacted very slowly to the low frequency songs that came next. When we played low frequency songs first, they really didn't differentiate between low and high. And so what we think is going on is that there's two things are happening, and they're compounding. So that chickadees respond more quickly to high because they can hear them better, and they respond more quickly to the first stimulus they hear because it's new, and they're kind of like, whoa, what's that? And so what happens is here you kind of get a doubling of the effect. So it's the first stimulus and it's the most audible. Here you're getting a bit of a muddying of the effect where they're responding more to the low because it's the first stimulus, but they're also responding more to the high because they can hear it better. So you're not getting that differentiation. With mountain chickadees, we found that the males reacted more aggressively to high frequency songs than to low frequency songs, but only in the noisy treatment. So this is evidence that they are more audible, because if it was aggression, we would expect a difference between these 2 stimuli in the quiet treatment. So playback studies are always complicated. So what, in a nutshell, does this really mean? So in black-capped chickadees, we did have quick reactions that suggest that high-frequency songs are more audible, but there was also this effective playback order that made the results a little bit muddier. Whoops. With mountain chickadees, in the noisy experiment, males differentiated between the stimuli, but in the quiet experiment, they didn't differentiate, which suggests that songs with more high-frequency notes may be more audible in noise. So we do have evidence that these changes the chickadees are making are helping them. So we've covered a lot, so let's sort of bring it back and figure out what are the answers to our questions. So we looked at signal propagation. We said, how do calls and songs travel through the environment, and how does habitat and noise affect them? So we know that noise interferes with chickadee signals. We know that with respect to signaling patterns, chickadees can adjust to noise, but the mechanisms between the 2 species differ. We know that adjustment can depend on the familiarity also with noise pollution. In terms of perception and response, we have that chickadees do differentiate between adjusted and non-adjusted signals. So in this case, they did differentiate between high and low songs. And there's some evidence for increased audibility from these high-frequency songs. So, well, obviously that's great because that means Steffi has a PhD and a postdoc. But we do want to put this into a broader perspective. So there are implications for this work beyond Steffanie's career. Some specific implications for chickadees suggest that black-caps might be more able to adapt quickly because they've got this built-in pitch shifting ability. They might still need to become familiar with noise, but they might also be just quicker to deal with noise issues than mountain chickadees. So mountain chickadees, we do have evidence that they do change the way they sing, so they do adapt, but they might be slower. And so this might mean that black-caps are sort of better urban adapters than mountain chickadees. Well, chickadees are all very well, but they're only chickadees. So does this matter in the real world as well, beyond the cuteness of chickadees? And I would argue that yes, it does, because birds in general are important. So with respect to the fact that urbanization is inevitable, we are increasing the populations that are living in cities. Every city, well, not every city, I shouldn't say that, but most cities are growing. We're having a lot of, we're changing the landscape quite a bit, and noise is just becoming more and more of an issue. Being able to look at birds' singing behavior and predict how that means that they will respond to noise should help us understand how these birds are going to react to this continuing urbanization. And if we understand these responses, we can help ensure protection for sensitive species. Because even though they're responding to noise, we found evidence here that the responses are probably to some degree beneficial, but we really don't know how beneficial. It's possible they're good. So we've got the good situation, where birds are changing the way they sing to deal with noise, and they're successfully adapting to urbanization. We also have the bad situation, and that's where this is really not great. Birds are changing the way they sing to make the best of a bad situation, but there might be trade-offs. Perhaps they're changing the way they sing in ways that increase audibility, but that reduce the effectiveness of the message that they're sending. For example, mountain chickadees, we talked about them changing from calls to songs and from songs to calls, but we actually don't know why they use both songs and calls during their chorus, and presumably there is a reason. Some people have speculated that songs are meant to be a signal to other males, and that the calls are meant to signal to females. So if males in noisy areas are switching from calls to songs, what does that mean with respect to how well they're communicating with their mate? This might have implications for sort of mating longevity, pairing longevity, and offspring. There's also the ugly, and that is, I don't think we saw that here, but it is possible that birds will they'll be attracted to urban areas a lot of the time by food provided. They'll stay here, they'll change the way they sing, which maybe will increase audibility a little bit, but also might compromise the way they're singing, or sorry, the message they're sending, but it may not actually help in the end. And so in the end, they might be doing all of this, and it still doesn't help. The analogy often used here is that sometimes when you're at a concert and you yell and you really try hard to communicate with people and you change the way you call, they still can't hear you. So sometimes enough, like your best is just not enough. So where do we go from here? So with respect to chickadees, I think the next question is really, are chickadees coping or are they struggling? Are there trade-offs between messages that they're sending and the audibility of these messages? In particular with mountain chickadees, what do songs and calls mean in the dawn chorus? We can also take this to a broader level here. So we got a lot of society perspectives. So as I mentioned at the beginning, noise annoys chickadees, and this problem for chickadees, but it also is really annoying for people. There's a lot of studies out there that show just how problematic it can be for people and how stressful. So what about noise mitigation? It'll help birds, and it'll also help us. So this has already been happening. There's also a lot of efforts made to kind of reduce the noise pollution, especially from highways. People, communities use special road building materials to reduce the sound from traffic. There's noise barriers. These ones are really fancy. You know, these ones are less fancy. And that's just a hedge, but they all work. And a hedge is a really great idea for a park because it also provides, it fits in, and depending on how you do it, it can also provide habitat. However, something I'd like to kind of point out is that perhaps in some areas we should just say that no noise is acceptable. The problem with a lot of our parks, particularly in the United States, is that we're losing this balance between the parks, what the parks' mandates are. So a lot of parks, they have two mandates. One is for protection of species and the environment and ecology, and the other one's for recreation. And that's to provide sort of fun and relaxation for people. But the problem is, when recreation includes helicopter rides, say through the Grand Canyon, that happen at really frequent intervals, you have this problem of constant noise pollution. So I know that some places, some parks, to get into certain access points, you have to take a bus, you're not allowed to drive, or you're allowed to walk in or bike in, but you can't drive in. So next time you have to do that and you're kind of annoyed about it, think about how much noise pollution you're reducing and sort of think better about it. So that's just something I think that as a society we could be aware of, that noise pollution, that we worry a lot in a lot of the parks about making them too commercial. But the more commercial they get, the more noise there is too. So there's another aspect to this, another facet to this problem. And I think I'll leave it there. Thank you very much.
Any questions? You mentioned it, you talked at the beginning, Steffi, you talked at the beginning about predation, predators, and then you kind of avoided that at the end. Is there a possibility too that as they start to sing at different frequencies, different volumes and so on, that they might be running into more predation problems? Or are the predators suffering from the same problem with the background noise and unable to?
That's a really good question. I'm not sure. I think with if they start singing really loudly, I think they might just sort of break even. I think, if you're singing loud enough to actually compensate for noise, then presumably you're not really changing much in terms of how predators can hear you. You're just, instead of not being able to hear you at all, they're probably able to hear you the same amount as before without noise. If you're changing the frequency, I really don't think it would make that big a difference to a predator. But yeah, I'm not sure.
Thank you, Stefanie. Thank you. I was just thinking that it would have been great if you had participated to the three-minute dance your thesis. You would have had plenty to.
I wanted to.
There was a lot of material possible.
And they canceled it. So the first year they had it, I wanted to participate in it, but I wasn't ready. And then after that, they never had it again. And they have it, I think, this year, but I'm not a student anymore.
We have to do it impromptu sometime. But the question I had was, are there birds that thrive on noise?
There are. Well, I mean, and I almost cheated a bit when I said that the increased predation in noise. There are predators that are auditory predators, and they actually suffer in noise. So birds that are being predated by auditory predators might do better in noise. But yeah, there is a really interesting study that talks about essentially community changes because of noise. And so they've gone out to gas well compressors and they turn them on or off. And they find that you actually change a whole cascade. You have a whole cascade reaction because hummingbirds like noise. And they think it might have something to do with predation, that it might scare away that they're predators. And so hummingbirds like noise, and so you get more hummingbirds, and so you get more flowers pollinated in this area. Scrub jays, on the other hand, don't like noise, and so they leave. But they also are seed dispersals, so you get more flowers pollinated in these species and less seeds of this other species dispersed in this area. So just by turning on a gas well, you've changed a lot in a couple generations, the ecology of the area. So it has trickle-down effects to plants as well. Sorry, I went off a bit on a tangent there.
I thought this was a really awesome talk. Birds have always been a big interest of mine. When you talk about regional differences between songs, is there evidence to suggest that the songs are learned behaviors, or that each chickadee would just cope with the sound as it happens? So if you took chickadees from one area and put them somewhere else, would their songs change or not?
Well, okay, so I'll answer the first part of your question and then try on the second one. So they are learned. They are innate and they're learned. So chickadees are born with a template, a singing template, but they have to hear and they have to learn their songs to get it right. So would they change? Black caps almost certainly would. I think they're fairly flexible, but you never know. But mountain chickadees, I have the sense that if you gave them time, they would figure it out. Simply because I find it hard to believe. They disperse so far, and the cities I'm looking at, so for the mountain chickadees, like Williams Lake, Kamloops, and Kelowna, they're not big cities. Like they're large, but they're not huge. And a baby that was born, or a juvenile that was born outside of the city might very well settle in the city. And I find it very hard to believe that you only have babies in the city settling in the city. And that's the only way you would get this different population effect if they weren't learning their songs. So I think that they are learning sort of a regional sort of population style song. So whether or not as an adult they could move and readjust, I feel like yes, but I have nothing to back that up. Any other burning questions?
One more quick question. I've noticed with chickadees, I can't help but hear them every day as I walk through the forest, but that song they have, they seem to vary those two notes by what seems to be an absolutely perfect full tone, full note difference. Is there any reason for that they would choose something that close to a full tone?
You mean like a musical
a full
tone?
note? Like a piano scale, you know?
Yeah.
Full.
I mean, and I have no idea. I think, I mean, it's a significant amount because it is used in pitch shifting contests. So males will actually pitch shift at each other, and if they overlap each other, that's considered a very aggressive signal. And so how well you pitch shift shows how sort of annoyed and who you're directing your contest at. It also how well you pitch shift and how well you maintain ratios between your notes as you go up and down is a very attractive signal to females. Yeah, so why it's the ratio it is, I have no idea, but it is a very specific thing, and if you change that ratio, chickadees don't respond to that song. And it is a very, if you mess it up, then the females are like, no, I'm not interested in you. I mean, and that's actually another thing I didn't even get into here, but it's that we know that it's easier for females to detect that well done ratio at lower frequencies. So if the male chickadees or black-capped chickadees are unable to shift to those low frequencies, they're sort of less able to show how awesome they are to the females. So that's another trade-off we have with the masking, sort of cutting things off.
Hi.
Hi.
Where's your recording of the mountain chickadee from? Because it sounds
I think it's
different
Kamloops,
to me.
yeah. I think it is Kamloops, yeah. Some of the birds, I know there's a group of mountain chickadees that I call them the three blind mice because they sound like fee, bee, bee, bee. But you also find that it's not only necessarily within Kamloops. Kamloops might have three different populations that have subtly different songs as well. And then I also found something I alluded to but didn't really get into here, is that in Kelowna they have some birds that sing really messed up songs. They sing, one reason why we did the playback study the way we did with all those high notes is because they sing fee, 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 and no BBs. Or on occasion, fee, 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 BB. And these are the mountain chickadees. So the problem was when it came to analyzing it statistically, there was a pattern, but it was in very few birds. So it was a very strong pattern in the birds where it happened, but it wasn't broad. So it was hard to say whether or not those poor birds were just not doing well in an urban area and just had really heard the songs incorrectly when they were learning them, which is why they didn't have the low notes. But maybe I'll go back to Kelowna in a couple of years and I'll find out that more of the population has this song now.
All right. Well, thanks very much again. So thanks to Steffi. And again, a reminder about next week's colloquium with Dr. David Connell.